Okay, from the test review sheet for the first test, Unit 1 and 2, the following picture, for number 9, the following picture shows two similar triangles. We need to find the values of A, B, E, and F if we've been given these parameters. So we need to match up our similar parts. So I have two similar triangles here, triangle ABC and EFG. So let's see, this is A, B, C, and G, F, E. So I need to make sure I match up the right parts. So my, let's just go ahead and call this A, B, C. That order of the first one doesn't matter. And as long, because I am kind of free to do whatever order I want here. But for the second one, once I've already picked that order for that first one, I got to be careful to match up the angles on both sides. So let's see, C is the right angle. That's the easiest one. So that's the last letter, which means our G is going to be the last letter. And then, let's see, side A is the shorter side, so it's a smaller angle, looks like. And that's going to match up with the F, because that's a shorter side, smaller angle. So that's F. And then the B will then match the E. So those are my two similar triangles. And once I have that, that tells me that side A is proportional to F, as B is proportional to E, as C is proportional to G. So that's, since the triangles are similar, those ratios are equal. Now I need to plug in what I have here. So let's start with, let's do A is 3x. Plug that in for right here. So that gives me the 3x. And B is 4x minus 3. So that's 4x minus 3. I'll just copy my equal sign and my fraction bars. And then I have E and F. E is 2x minus 2, so that's right here. That's under the B. And then the last one is F. Is x plus 1. That's this guy. So a couple things you want to be careful of here is that your ratios are consistent. So, for example, in mine, I have the numerator is always the ABC triangle. The denominator is always the other triangle. And the A and F are corresponding sides. The B and E are corresponding sides, and the C and G are corresponding sides. So that's what you want to be careful there. We don't need C and G since we haven't been given that information, and we don't need to find that information. So really, we're just focusing on these guys. Excuse me. Excuse me. I'm going to shrink this up to give myself a little space here to do some work. Okay. So what I want to do now is to solve for x, I need to cross multiply. So I take the 3x, whoops, sorry, I need a pen. 3x times the 2x minus 2, doing this cross multiplication, and then that's going to equal the x plus 1, and notice I'm putting it in parentheses because that fraction bar works as a grouping symbol. So I need to treat x plus 1 as a group, and the 4x minus 3 is a group. So when I multiply these together, I need to use the distributive property. So 3x goes to both the 2x and the negative 2. So I have 6x squared minus 6x on the left. On the right, I have to FOIL. So I have to do the distributive property with two binomials. I do first outside, inside, and last. So everything gets multiplied by everything. Well, everything in the first parenthesis gets multiplied by everybody in the second parenthesis. So that gives us, the first is 4x times x, so that gives me 4x squared. Here, let me actually use some colors here. So the 4x squared is the first, so that's the 4 times the 4x. And then number 1, so that's the F of FOIL. And then outside, let's do orange. The outside's the x times the negative 3. So that's going to be minus 3x. And then I for inside. So that's the 1 times the 4x, which is, and then our last piece is, let's do purple, L for last. And that is the 1 times the negative 3. Okay, now I can combine like terms, simplify this a little bit. My only like terms are those center two terms, so negative 3x plus 4x gives me x, and then the rest of it I just copied down. I haven't changed anything else. Okay, so I have 6x squared minus 6x equals that. So it's a quadratic, so I need to get everything on the left-hand side, and on the right-hand side just have 0. So setting it equal to 0 is the first step to solve a quadratic. So I'm going to subtract 4x from both sides, 4x squared, sorry. And I'm also going to subtract an x from both sides, and I'm going to add a 3. So that everything on the right turns to, I'm going to come over here. Everything on the right is now 0. And on the left, I have 6x squared minus 4x, which gives me 6x squared minus 4x squared gives me 2x squared. Negative 6x minus x gives me a negative 7x, and then add 3. Okay, now I need to factor this guy. So to factor a quadratic, I like to use the x method, which is a times c in the top and b in the bottom of this little x. And the a times c, that's 2 times 3. So remember, a quadratic is ax squared plus bx plus c. That gives me the form of a, b, and c. So that's 2. Just to note though, this is my quadratic language. It's not the same a, b, and c as this. So I'm actually going to cross that off to avoid that confusion. But on the top, I put the leading coefficient and the constant. So 2 times 3, which is 6. That's the last one and the first one. And in the bottom, I put that middle number, which is negative 7. So now I have to think, what will multiply to 6 and add to negative 7? That's going to be my two numbers here. So my factors of 6 are either 1 and 6 or 2 and 3. And that's it, because then the next one's 3 and 2 and 6 and 1. So once I've got down about halfway, then I'm done. So 2 and 3, if I add those together, I don't get negative 7. But 1 and 6 work as long as I make them both a negative. If I multiply a negative 6 and negative 1, I get positive 6. If I add them together, I get a negative 7. So 1 and 6 is our magic numbers. We're going to take that 1 and 6 and replace that negative 7 with it. So when I add those together, I get that negative 7. So that's actually going to be negative 1x minus 6x. And then the plus 3, I'll just bring down. And the 2x squared, I'll just bring down. And the equals 0, I bring down. Okay, once I get to this 4-term quadratic, I'm going to split this into two groups. The first group is here, And then I'll say that plus running out of colors here. This is my second group. That negative stays with that 6x. So I have a little plus between them. So I'll just bring that plus down. And I have, from that green group, I have 2x squared minus 1x. And from that orange group, I have negative 6x plus 3. And all of that equal to 0. From that green group, I want to take a GCF. So the greatest common factor of this green binomial is an x. That's the largest number I can take out of both terms. So taking an x out of the first term gives me 2x, and the second term leaves me with a negative 1. Now I still have that plus sign that has to come down. And then in the orange group, my goal is to make, after I take a GCF of that second group, the insides to match that. So if I take out, I can see I have a GCF of 3. If I take that out, I'll still have a negative 6 and a positive 1. Negative 2 and a positive 1. So I'm going to take out the negative also. So that way I can get the signs to match up. So when I take out a negative 3, divide that first term, negative 6 times x, by negative 3, I get 2. And divide that second term, 3 divided by negative 3, I get negative, I forgot my x. 2x minus 1. And that matches. So let me grab a little highlighter there. So I want this thing to match this thing. Now I'm going to look at this term and treat that 2x minus 1 as one object and call it it's like the GCF of this. So I'm going to take that 2x plus 1. I guess I'll do yellow since I have it highlighted in yellow. Sorry. Okay, so I'm going to take a 2x minus 1 out. And what I'm left with after I do that is the x plus a negative 3. I can also just call that x plus a negative 3 is the same thing as x minus 3. Okay, so I have two factors now. These are multiplied together, and they're still equal to 0. And so that came up from when we solved the polynomial, quadratic. So if two numbers multiplied together equals 0, that means one of them must be 0. That's the only way a product can be 0. So I know either 2x minus 1, I should do that one in yellow, 2x minus 1 equals 0, or x minus 3 equals 0. So to solve for x on the right, I have x equals 3, or in the yellow one, I have solving for x, add 1 to both sides, and then divide by 2, and I get x equals 1/2. Okay, those are my possible solutions for x. And our goal here is to find a, b, e, and f. So I got to take those back up here and see which one's going to work. So if I take a half, if x equals 1/2, then when I plug it into this guy, for example, then I get 2, if I get 4, if I were to plug that in here, I get 4 times 1/2 minus 3, which is 2 minus 3, which is negative 1. And we're saying that side B is negative 1, which is not possible because it's a triangle with sides that exist. So it's not going to be negative. So that eliminates this possibility. So that is not an answer. So our only option then is this guy, the x equals 3. So I have x equals 3, and then I have to plug that in for a, b, e, and f. So I'm going to shrink up my work again so that I can make some space to do that. Kind of a mess there. Get rid of this stuff. And remember, we crossed that guy off as not possible, and we said x equals 3. So we have x equals 3. So that means a equals 3 times 3, which equals 9. B equals, oh, I should stick with my colors, huh? So a equals 3 times 3, which equals 9. B equals 4x minus 3, so 4 times 3 minus 3, which gives me 12 minus 3, which is 9. E is 2x minus 2, so that's 2 times 3 minus 2, which gives me 4. And F, which color? F was x plus 1, so that's 3 plus 1, which equals 4. So there's my answers. I'm actually just going to say a minus equals 9, b equals 9, e equals 4, and f equals 4. So it turns out these are 45, 45 isosceles triangles, not drawn to scale, as you can see. And that is my final answer.